Today we're going to be looking at lesson 3 of chapter 5, which is properties of operations. Okay, this lesson is going to be starting in your book on page 367. The first place that I would like you to take a look at is the middle of the page underneath the pink bar where it says the real world link. What we're going to be looking at today are different properties that you guys are going to encounter and that you are going to be learning about. Okay. There are a few vocab words. Actually, you have 7 vocab words that you will be looking at and completing for lesson 3 that you will need to complete in your vocab map. The other thing to take note is that the properties that we're going to be talking about today in lesson 3 are also posted along the east wall of our classroom. And so if you ever need help or get stuck or want a refresher of something, please feel free to take a look at the wall in the classroom. Okay. First of all, they're giving us a situation. It says, Mrs. Ricardo drives up and down her street to complete different errands. Some of the places on her street are shown below. The number of blocks between the places are also shown. Okay, so you can see here, first of all, they have her house. We have 2 blocks. You've got the library, you've got 1 block, you've got games galore, and then you have 3 blocks, and then your football field. Okay, one of the things we're going to be looking at, first of all, is, let's say Ms. Ricardo is moving back and forth between these. Okay, we're going to be putting together expressions using our properties that we're going to be learning about to help us describe what is going on. Okay, number 1 says, suppose Ms. Ricardo drives from home to the game store and back. So she's going from home to the game store and then she's going back. Okay, write an expression for each distance from home to the game store and then also from the game store to home. One of the things that I want you guys to think about as you're writing this is when she goes from home to the game store, so from here to the game store and then from the game store back, her actual overall distance is not changing. Okay, her overall distance is not changing. So if we were to write an expression for this, okay, from home to here, I know it's going to be 2 blocks, okay, plus she's got another block here to the game store, so technically we're looking at 2 plus 1, okay. Now from the game store to home, so I'm going backwards, so game store to here is going to be 1 block, and then another 2 blocks to home. So when I take a look at these 2 expressions that I've written, 2 plus 1 and 1 plus 2, one of the things that I want you to take note of is what's different. Okay, what is different in it? My numbers that I'm using are the same, okay, and my operation of addition is the same. The only thing that has changed is the order. Okay, so instead of writing it as 2 plus 1, I am now writing it as 1 plus 2. Because the order is changing, what we're looking at is we are looking at the commutative. Okay, so commutative property of addition is what we're looking at, and of addition because we are adding. When you think of commutative, think of the word commute. Okay, when you commute, that means you're going from one place to another. In the morning when you get ready for school, you are starting at home, you go from home to school, and then at the end of your day you go back from school to home. As long as you're not adding in any other trips in there, your distance from home to school and school to home is going to stay the same. Okay, just like 2 plus 1 is 3, same as 1 plus 2 is going to be 3. So we're looking at commutative property of addition. Okay, so you can see here on number 2, we would be circling your commutative property. Okay, next situation is asking us to write an expression for our distance. So they changed it up a little bit. It says on Monday, Miss Ricardo drives from home. Okay, she's going to stop at the library, and then she's going to drive to the football fields. Tuesday, she's driving from home, stops at the game field or game store, okay, and then drives to the football field. Write an expression for each distance. So again, using your graphic that we have up top, we're going to be looking at our distances. You're going to notice that if she drives from home to the library, okay, we're looking at 2, plus, then she's going to drive from the library technically to the football field. So in that case, we're looking at 1 block plus 3 blocks, okay? Then on Tuesday, she's driving from home. She's stopping at the game store, okay? So in this case, we're going to have 2 blocks plus another block, okay? Then she's stopping or going to the football field, so we're going to end up adding on 3, okay? So one of the things that I want you to take note on this one is what's changed. Okay, what has changed? So as I look at it, I've got the number 2, I've got the number 1, and I still have the number 3. Okay, I'm still adding on both expressions. What has changed is on the first one, I grouped together the 1 plus 3, and the second one, I'm grouping together the 2 plus 1. Okay, because I'm changing my grouping, okay, what happens is I'm looking at an associative property of addition. Okay, so in this case, when we're talking about our properties, we're going to be talking about associative of addition. Okay, and what that means is one thing that I always say to remember associative is I always say, well, who do you associate yourselves with? Okay, when you think of association, you're kind of like, who are you grouped with? Okay, and parentheses are used for grouping. So association, who do you group yourselves with? Some of you might group yourselves with a group of girls. Some of you might say 7th grade girls. Some of you might say 7th grade boys. Some of you might say basketball players. Some of you might say softball players. Some of you might say wrestlers. Okay, those could all be groups that you could be a part of. So again, by using our parentheses, we're showing our grouping there. Okay, we're going to go ahead and take a look at page 368. On this page, you're going to notice that they have a lot more properties that we are going to be working with. Okay, so what I would like you to do is direct your attention on the top of 368. Okay, please take note that they have your commutative property here. Again, when you're thinking commutative, you're thinking almost a home to school and then a school to home situation. Your distance is not changing. The only thing that changes is your order. It works for addition and it works for multiplication. Okay, example like 7 times 3 is the same as 3 times 7. 6 plus 1 is the same as 1 plus 6. Okay, will not work for subtraction or division. Okay, it will not work for those. Next one, associative property. Again, this is who you are grouping yourself with. Okay, who do you associate with? Okay, so when we're thinking about associative property, okay, you're changing the grouping. Your order of your numbers does not change. You're going to notice 2, 3, 8, 2, 3, 8. Numbers do not change. Okay, and the order of numbers do not change. What changes is your grouping symbols. Okay, below that, you've got a couple other ones that we're going to be looking at, other properties. And again, these are also located on the wall too, so you can look at those. Additive identity, sounds like it is. Additive, adding, identity, you're adding the same number. Okay, so you're going to add 0. Okay, basically anytime we have a number and add 0, we're always going to get the same number. Multiplicative identity, just like it sounds, you're multiplying. Identity, you're going to ask yourself, what number can you multiply times another number to keep it the same? You're going to be multiplying by 1. Okay, so multiplication, you're looking at multiplying by 1. On additive identity, you're adding 0. And you can see the examples over here. Multiplicative property of 0, just like it sounds like, multiplying, and you're multiplying by 0. Okay, product is always going to be 0. So any number times 0 is going to be 0. What I would like you to do is go ahead and take a look at example 1 here. You can see one of the things you're going to be asked to do is to explain what property is being shown, and then pause your video and go ahead and complete A and B on the bottom. As we take a look at A and B on the bottom, we're looking at what type of property is being illustrated. So I have 42 plus x plus y equals 42 plus y plus x. What has changed? 42 is still in the same spot. X is now y is now x. So if you think about it, what's changed is your order. Okay, and anytime we change the order, we're looking at commutative property, and we're adding, so it's going to be commutative of addition. Okay, over here I have 3x plus 0 equals 3x. Okay, well, looking right here, I'm adding 0. And you're going to want to remember, anytime that we're adding 0, we're looking at additive identity. So hopefully below it you have written down additive identity, because those would be the two properties that are being shown there. Okay, next example on 369. Okay, we're talking about a counterexample. Counterexample goes against. Okay, basically we are showing that your conjecture is false. You are showing that something is false. Conjecture would be a statement. Okay, conjecture would be a statement. So you're showing that your properties are not going to apply. Right here, they're giving us division of whole numbers is commutative. Commutative meaning you can change the order. So one of the things you're going to want to ask yourself is, if I take 8 divided by 4, okay, is that the same as 4 divided by 8? Okay, well, this is the conjecture that they made. Technically, this would be a counterexample. This is not true. 8 divided by 4, okay, would be 2, but 4 divided by 8 would be 1/2, so it's not going to be true. they give you another example right there that you can see. Okay, let's take a look at this one. The difference of two different whole numbers is always less than both of the two numbers. So let's look at some situations. Talking about whole numbers, if I take 9 minus 3, okay, again, that's difference. 9 minus 3 is 6, okay, so 6 is my answer. Is 6 less than both of those two numbers? Well, 6 is less than 9, but it's not less than 3, okay, so that would be an example of a counterexample, okay, it goes against this statement because it's not true. Example 3, they're giving you a situation. One of your jobs is to use mental math to find your total cost. When you're looking at using mental math, you want to regroup or change your numbers so they're easier to add. Okay, so you can see here they've got 38, they have 14, they have 16, and they have 22. We're looking at the total, so we would be adding them up. If this was my problem to solve, I would technically group 38 and 22 together, so I'm looking at the commutative property, I'm changing the order of it, and then also the associative property because I'm going to group those two together. Reason why I'm grouping those two together is because those are two numbers that I can easily add together in my head, okay, because we're supposed to be using mental math. The other pair of numbers I would group together would be 14 and 16, okay? In my opinion, it's easier to add 14 and 16 together than 38 and 22 together and then combine them than it would be to take 38 plus 14 plus 22 plus 16. So you can see the example that they have given you down here showing you, okay, they change the order, which is commutative property, then they're grouping those together, which is your associative property, to come up with your answer, okay? If we take a look at letter D, practice problem letter D again, think about your properties that you can use to solve this. Where you're looking at mental math. Lance made 4 phone calls from his cell phone today. The calls lasted 4 7/10, 9.4, 2.3, and 10.6 minutes. Use mental math. I'm thinking I would probably group 10.6 and 9.4 together. Reason being, I know 6 plus 4 would give me 10, so that gives me a 0 there. I can carry over 1, 10 plus 9 would be 19, plus another 1 would be 20. Okay, so again, I'm technically thinking 9.4 plus 10.6. I'm going to group those two together. Okay, and then I'm going to group together 4.7 and 2.3. Again, 7 plus 3 would give me 10. That's easy mental math. And then I can carry 1 over, so 4 plus 2 would be 6, plus another 1 would be 7. So again, I'm thinking 4.7 plus 2.3, and those would be grouped together. Okay, and so like I said, my number there would be 7, so 20 plus 7 would give me 27. So what's the amount of time they spent on the phone? 27 minutes. Okay? One thing that you may want to do is go back and kind of look at your properties, again, which are on page 368, and take a special note of those specific examples that they have given you. Once you've read through those and kind of looked at those other examples a little bit more, then you can go ahead and start working on your practice problems, which your practice problems are going to be your extra practice problems on page 373, starting on page 373. So please take note of the website in terms of which ones I would like you to do.